Okay, so this is problem number 11 out of page 111 of chapter 3 of our textbook. It tells us that the 150-pound grate is supported by cables AB, AC, and AD, and that we need to determine the tension in these wires. So our first step in solving this is going to be to create a free body diagram using this photo that they give us and drawing one out on our paper. Then we will have to find the components of forces using the distance in feet that they give us. Here is my free body diagram from the photo that they give us in the book. We have a tension C going in the direction of point C. We have a tension B going from point A to B, and then we have a tension D from A to D. And then we have a tension downward from A to E of our grate. Next, we need to find the Cartesian vector coordinates of our points C, B, A, D, and E, and use them to find the components of all of our tension forces so that we can later solve. So here are my points A, B, C, and D as a Cartesian vector. And so now we need to solve for the components of the resultants of AB, AC, and AD. So how can we do that? Since A is our origin, we take our, for instance here, we take our B and we will be dividing it by the square root of each of the X, Y, and Z components of B, which end up equaling 7. And we then we divide them to get negative 0.857 I for AB, and then the J, and then also the K. And so we're going to do that for all those. And that comes from the equation R equals the tension resultant over the resultant divided by the magnitude of the resultant. And since our AD and AE both are only going in one direction, we can just write, they will just be comprised as a single component of the AD being only in the X direction and the AE only being in the downward C direction. And now we can take all of that and we can rewrite them as tension vectors components and begin and create our equations. So the sum of the forces in the X is going to be equal to our tension in the X, which is our tension AB in the X, which is equal to negative 0.857 minus 0.857 TAC plus the tension AD set equal to 0. And then we can take the sum of our components in the Y and set them equal to 0. So it's 0.429 tension AB minus 0.286 tension AC, since that's acting in the negative Y direction, and we set equal to 0. Then the sum of the forces in the Z will be equal to 0. So we'll have 0.286 tension AB minus 0.286 tension AC minus 150, which is our tension AE, will be set equal to 0. And then we'll mark those as equation 1, equation 2, and equation 3. Next, we're going to use a system of equations to solve them. In our 3 equations here, we can see that equation 1 has 3 different variables that we have to solve for. So that one doesn't help us much at first. But when we look at equation 2 and 3, we see that we have 2 equations, both with the same variables, and one with a possible solution. So we can take these 2 over, and we can play around with some multiplication, in this case being 0.286 over 0.429, and up top here is equation 3, and equation 2 is down here. And when we multiply it, our TAC, when we multiply equation 3 by that, the 0.429 TAC will become 0.286 TAC, and they will end up canceling out, leaving us with 0.2620 TAB set equal to 100, which equals 100, which is the result of all of this being multiplied by 0.286 over 0.429, and then us summing it up. And now from this, when we divide 100 by 0.620, we find that TAB is equal to 161.4 pounds. Now that we have TAB, we can plug this back into our equation 3 to solve for TAC. So we plug in 161.4 over here. Do the math. We'll get 0.429 TAC is equal to 103.8, and so TAC will then be equal to 242.1 pounds. Now that we have both of these, we can plug them into our equation 1 to solve for our tension AD. Just down here, so this is 0.875 times 1.61, that's our TAB, minus 0.857, which is our times 242.1 pounds, that's our TAB, plus TAD has to equal 0. So TAD will be equal to 345.8 pounds. So these are all of our. So tension AP is equal to 161 pounds. Tension AC is equal to 242 pounds, and tension AD is equal to 346 pounds once we solve for them and round to 3 sig figs. And that's the end of this one.